Yo, what's up, everybody? Welcome back. Today, we are working on our code visualizer, and today's topic is to try to pretty this thing up a little bit. The intent of this thing is that we are trying to find some way to provide at-a-glance information about our code base, so that when people jump into a stream, they come in and they're like, "What's going on?" As I'm jumping around the code base in my editor, we want to provide some sort of like context for what is being done, right? So the idea here is that the text editor will be hooked up to this graph. This graph will show maybe somewhere like a little legend, right? He'll say, "Oh, we're in this section over here." Like right now, what you're seeing, this yellow highlighted section, this is the math library, right? And you can see it's kind of in the center because like a lot of people are using the math library around the whole code base, right? So I'm kind of hoping that we'll jump around. We'll maybe pick a few places, right? If I'm working on like the text renderer, we might see that like I'm spending 30% of my time in the text renderer file, maybe 10% of my time in the TTF text loading stuff. Maybe I'll be spending some time in like the OpenGL section, and it would be kind of nice to like kind of highlight those parts of the graph somehow, and maybe provide like a legend that says like, "Hey, the yellow thing that you're seeing, that's the math library. The blue thing that you're seeing, that's this thing, and this is how they relate to each other." Um, that's the goal, right? We're not really there yet, but another goal is we want it to kind of be pretty and fun to look at, right? So today I wanted to look at. We're trying to solve this problem of like there's two ways that things are connected. Things are kind of like hierarchically connected to each other. So like functions in a structure are part of that structure, and that structure is part of some file, and that file is part of some library, right? And so there's also things use each other, right? So we kind of pull each other toward we pull these nodes towards each other based off of how they reference each other and their parenting. But I think we want to visually show like the parenting as well. So what we've done so far is we've kind of made it so that parent pulling is like stronger than the reference pulling, and the idea there is hopefully that like modules will kind of pull each other around. And we also, as of yesterday, have this way to generate like a convex hull, so we can take a set of points and we can like maybe put a background behind those points. And I'm hoping that we can kind of like take those two things and make something pretty. Um, we were experimenting with the idea at some point as well of like weighting the graph. This is kind of ugly because of this convex hull we're drawing. But the idea here was that maybe if we're spending most of our time in text renderer, we want that thing to be bigger. I think I've kind of changed my mind on that a little bit. I think that I'm kind of more interested in the idea that everything has like a fixed-ish location in the graph. Obviously, the locations will change as functions pop in and out, as like more code is added and removed, etc. But like somewhat stable. And I maybe am imagining that like these things could be viewed as like stars, and like maybe the brighter a star is, the more time we're spending in that section. So I kind of want to try like making this thing look a little bit more like that. I feel like stars kind of fit well because when I was looking up the other day, like I noticed that like some stars are bright, some stars aren't. Wow, huge! I should be like a first century philosopher. Some stars are bright, but uh, like they're all effectively really fucking small, right? In terms of like absolute space taken up on my like in my eyeball of the thing itself, they're all small. But like some things we can see more than others because they're brighter. And I'm hoping that like maybe we can kind of leverage that here as well. So like we can keep everything small, but some things are really bright and those draw our eyes. I was also looking at these like lens effects that things have. So if we just look up like I don't know space wallpaper, this is kind of like a good like thing that we can use for inspiration. I feel like so maybe something like this, maybe something like this. Um, in a lot of these like fake photos, right? Obviously, we're not really going for realism here. You get this like kind of like lensing effect where you get like these like crosshatches or whatever the fuck you want to call them, right? So maybe we can try to say that like as something gets like brighter, we kind of get like a bigger section that looks like this. I don't know. And then I also wanted to play with like maybe different segments of the code base could be kind of like backgrounded by some sort of like galaxy-esque type shit behind it, right? I don't really have much more of an idea than that. I'm just kind of thinking like there's definitely some way to show like backgrounds for stuff as well as like brightness for stuff. So let's just kind of like poke around, play around, see how if we can make this thing look a little bit less shit, a little bit more like I don't know, pretty. And try to provide some more information while we do it. So let's just jump in and try to figure it out. Okay, so. Let's start with the idea of these like weightings. So we did have we do have the concept of weight already. We used that to kind of adjust the way that like things were pulling each other in their size. I want to first strip that code out and try just applying it to brightness first. So let's look at the graph here. Somewhere we must have some sort of like weights usage here. And on each step, I'm sure that like all of these pull and push things relative to the weights should just not take the weights anymore. I assume if we don't want like the positioning of the nodes to change, then I think we just kind of take this away, I think. So let's just, I don't know, move our way through here. And see. Weights. Okay. This is just probably these were doing like weight-based pulling, so the big thing was pulling the small thing more than the small thing was pulling the big thing. We want all of this to go away, so we just say bidirectional pull is probably equal. Right? Probably. What is like the type of this thing? Movements. Movements is vec2. So we should just be able to do like splat into a vec2 pull over 2. I think. Maybe something like this. That feels right to me. That feels right. Okay, so now this guy is using weights on a pull as well. Looks like we can kind of just start deleting that. Weights as well, delete. This is using weights to do what? He's increasing push between elements based off their weights. We can just ignore that. And then weights doesn't go in here anymore. Okay. This guy's mad. Pull towards the center. So I think things that were higher weight were being pulled towards the center more. So just kind of fuck that shit. Okay. We messed this up a little bit. So pull was already a vec2. So it's actually, we want to do pull over a 2.0 kind of splatted into a vec2. So this just basically says like make every field of a vec2 2.0 so that when we divide, it's divided by 2.0 in each dimension. Should be fine. Okay, so nothing should have changed, really. We should be seeing like the same shit. Which I think we are. Eventually, this stabilizes into something that looks relatively sane, and now as I increase this, the sizes are still changing, but they're like, their movements are not. So that's kind of fixed that. What is the information source for code relationships you're feeding into this? It's, we use language servers as well as language servers and tree sitter to kind of walk the code base. Yeah, that looks fine. Looks fine. So yeah, what is it? It's we walk the code base using tree sitter. Tree sitter, we have like rules on how like which things in tree sitter are interesting to us, like container field, struct declaration, as well as rules on how to move towards like the identifier for a thing. So when we find a struct, we say go to our parent, we should be this type, and find the first child of a variable declaration with this identifier. That's the name of the thing. We ask a language server for all of the references for each of the things that we find, and then we build up a little database of those things. Okay, so now we just need to remove that like sizing thing. So that is, the tool will work for many lengths probably. Yeah, exactly. Tool seems like an awesome idea, potentially other impulse of the idea. Well, I mean, I don't know we'll see if it ever ends up being useful. As of right now, this thing is completely useless, and I'm not really confident that it will ever not be useless. But if we get there, that would be exciting. So I guess update highlighted are update points. Update points. Somewhere we're rendering here with the point radius, which I assume. Oh, we pass in the weights here and the point radius. I see. So we multiply the size of our thing by the weight. Okay. And the question is maybe. The question now becomes, how do we make it so that as we get bigger, like what does a bigger star look like in this world? In these like shitty fake examples, right? I think that the really small ones, I think there's like this kind of like hot center. And the center as like we could imagine drawing like a box around this whole section, right? We can imagine drawing like this box here. Let's pretend this thing is axis aligned. I think that as the box grows, the center kind of grows a lot slower, right? So we kind of have this like heat thing in the middle. And this thing grows very slowly relative to this. But these lines that are coming out of him, these grow a lot. So I wonder if just expanding this thing will kind of work itself out. Or if we kind of have to, maybe we pass in some like metadata about how like stretched it is or something. Zephoid, thanks for the prime, much appreciated. This looks so cool. This looks cool. So the points in the node will render the object names, or is it just to visualize the connections? I do think that I want like a legend. So I think that what's going to happen is my current idea is that I'm going to look at like the previous like 4 interesting pieces, right? And each of those pieces will probably be rendered in like a different color. So we'll have like 4 nodes that are like different colored and bright. And then I think that we'll have like a legend somewhere that says like the purple thing is this class. That's kind of what I'm thinking right now, but we'll see how it plays out. So we could try doing something like that. What if we go to Shader Toy and just try making, I don't know, something. So can we make this thing like, does it have to be 16:9? Can we choose a different resolution of this thing? Shader Toy aspect ratio, maybe not. We might not have a choice. It's fine. So do we have like uniform? I guess we would just change the uniforms in like in our file here. Okay, so let's say that we want like just like a circle in the center. Is frag chord in pixels here? Like let's just say we do like frag color is equal to vec for frag chord like this. How does this show me something interesting? No. Okay, so probably in here, if we wanted to start playing with this thing, frag chord is probably in unit of like resolution of the image. So we probably have I resolution as well. We don't have like UV coordinates. That's fine. That's fine. So like vec 2 UV is equal to frag chord over I resolution? Question mark? Does this work? Wrong type. This does not allow. Oh, I see. XY maybe? Okay, there we go. We've got our kind of like UV coordinates now. We kind of know what we're looking at. And then can we also kind of like limit this to a square? Does that make our lives easier? It might. So we might be able to say like UV dot X divides equal by divide equals. We want like 0 to 1 UV. We want this to turn into like negative something to something else, right? So we want like, is there like a lerp in GLSL? Mix, sure. So we say we go from, I guess, okay, so what is our like, if we're trying to make this thing square, we have 16 by 9 or something, right? We have I resolution dot x over I resolution dot y. That's the aspect ratio in some way, right? So I guess we're trying to make it so that the x goes up faster than y, right? So we're going to do like uv dot x times equals aspect, I guess. He doesn't like this because I probably forgot a semicolon here or something. And then can we say like, if uv dot x is greater than 1.0, discard? Why doesn't he like that? Maybe discard's the wrong word here. Can we return? Okay, there we go. Is that square? That seems square to me. That seems square to me. And then can we do like uv.x plus equals aspect over 2 question mark? No. Yes? Maybe? Maybe 2.0f question mark? Nope. Minus equals 2.0f? Aspect minus equals, I guess we want to do like, if this is over 1 or uv.x is less than 0, and then we do like the x shift here. This needs to be the other type of OR, like this. Nope. Other way, I guess. Maybe we should like think a little bit with our brains, but what if we just kind of eyeballed it? Am I crazy? Am I crazy? If we have like, if we have 9, 16, how much do I want to shift this? I want to do like, I want this to be 9. This is 9 pixels here. So I need to offset this by like 16 minus 9 over 2, question mark? I guess. So this is x minus y over 2. But then this is in like normalized space, which makes this a little bit more confusing. So this is going to be divided by 9, divided by y. Sure. I don't know. I guess it doesn't really matter. Fuck. I resolution. I must have spelled it wrong in one of these. If syntax error, probably forgot a semicolon. There we go. We got it centered, baby. Thinking with our brains in 2025? Yeah, I know. Crazy. Okay, so we have now a square that we can play with. We have a square we can play with. Now let's say we want to make like a star. So I guess we have like, we can imagine that it probably has some sort of like exponential fall off, right? Like, we're not trying to do like a solid center. We're trying to do something that looks more like this, right? So what is this? How do I make like a little bump? Like, what function is this? function, like bell curve function. Bell-shaped function. Give me something. Gaussian function, A, E. Okay, what are like B and C here? Normal distribution. Jesus Christ. Okay. So we have like, do we have E in GLSL? Exp, we do. So we can just do like, so what are our constants here? A is going to be like the maximum value, right? Because this is going to multiply like the Y value. So the distribution part is just the E part. And then X minus B is the center, probably. And then C must be the actual interesting like spread. It must be. So we're going to do exponential of like negative x squared over 2c squared. And then we just take the fucking, do we need that too? Maybe. Maybe. X. Okay. Negative x squared. So uvx times uvx, right? Is that what we're talking about here? Yeah, over 2c squared. So this is going to be like 2 over c over c, and then I guess we need some sort of like float c is equal to 1.0 or something for now. And then exp takes in this thing and returns a float. So if we say that like, I don't know, float r is equal to this, then we do like r0 v. Fuck! Wrong operand types. Probably 2.0 f here. And frag color syntax error, probably because I forgot semicolon. Oh, this is centered around 0 though, so we want to do like center dist. We'll just do this in one dimension for now, and then we'll figure out the rest later. So the center dist here is going to be absolute value of 0.5, which we've defined as the center, right? So it's just uv.x plus 0.5 question mark minus 0.5. So this will make it so that if x is 0, we're at 0.5 away, and if x is a 1, we're at 0.5 away. Yeah, that makes sense to me. So then we use center dist here. Okay. Fuck. Forgot a semicolon. Now everything's just like way too fucking bright, which means that we probably want to increase C, I assume, right? If we make C like really fucking big here, it's actually the other way around, huh? Can we like look at the fucking graph of this thing? Maybe Desmos is better. E power of negative x times x over 2 times c times c. Okay. So c is what we thought. C is kind of like the speed in which this thing falls off. And I guess we want him to go down to like 0 fairly quickly, right? So I guess we want like a C of like 0.1 or something here. Okay, cool. That seems reasonable. So then we can play around with like, can we like put, this thing doesn't have like sliders or anything? That's okay. That's okay. X is going to be pretty sharp, but we have like a choice, right? We just get to like move the slider, I think. And I guess we want it so that we're kind of target like 0.5 is kind of like the full thing. So yeah, I guess 0.1 here is fine. It's fine. Okay, so now we're going to change this to be like circular, right? So this center dist is going to be what? So you have like a circle. You have circle. The most that's the most we've thought today for sure. So circle, we have point. We have point here, we have point here, right? How far is this? A squared plus B squared equals C squared. Okay. Okay, so this is gonna be like the squirt of I guess we do like first we find the distance in x and y. So this is going to be like uv minus 0.5 in both dimensions should give us the like center offs. And then our center diff, right, so this is a vec2 here. Our center dist is going to be, is there like a length in this thing? Can I just do this? I'm kind of sick. Oh, hell yeah. I don't have to fucking think at all. Oh, baby, that's a fucking thing, if I've ever seen one. Okay, so let's make the background, like, just not black, just so that we can see how this thing fits in the square that we want to look at. So maybe we just do, like, this? Yeah, there we go. Just so we have, like, something to look at. Just so we have something. Okay. So now it feels to me like we want this thing to actually be way smaller relative to, not that small, that's way too small. Actually, let's look at our reference pictures again. So something like this. Like this guy's taken up maybe like 1/10 of the entire area. This thing's bigger than that. So can we go like smaller? What if we did like 0.5 here? Okay, that seems kind of good. Now let's just try to figure out how to get the like vertical, horizontal, stretchies, you know? So what? We have like, is it just the same thing? Let's look at the picture again. So we can kind of imagine that this thing is kind of like thicker in the center and tapers off as it gets farther away, right? It kind of feels that way. It feels like there's like definitely like directionality to the thing. Actually, arguably looking at this, it kind of stays the same thickness the whole way and just kind of like fades out. So maybe this is just like the same thing, maybe. Is there like another parameter we can use to like stretch the top of this thing, like relative to the bottom? Like if I want something that's kind of more like fat up top, right? Is there like a difference between like this and like this, you know? Vertical and horizontal things, you mean the lens flare? Yeah, I think that is lens flare. I don't really know if I understand what it is. You know, it's like kind of different. Yeah, like what is this shit? Why does it look like that? Physically, like, not that this matters, but I'm kind of curious now. Shape of an aperture. Bright source is shining on the lens, but not as field of view. Lens flare appears as haze. But like, what is it? You know? Artifacts and glare. Glare makes the image look. I don't care. I'm not gonna figure this out right now. The cross. No, I like understand that, but like, it's from the mirrors. Oh, okay. Sure, maybe. I could see that. Try with integer power higher than 2. Yeah, nice. Good eye. Good eye. Good eye. So the problem here is that we need the power to be a, does it need to be like an integer multiple of 2 here? Like if we just do like pow x like p or something, or I guess in this it would be like x to the power of p or something. Yeah, there's something fucked here. But we could just absolute value the input. and then it kind of fixes itself. Right, we're gonna do this. Oh, that feels kind of good. That feels kind of good. Let's do that. Let's do that. Where is our shader toy? I also hope that we don't lose this if something goes wrong. So let's call this like, I don't know, Bell. And this thing will take in a P and C, we called it, right? And X. I guess we probably have to write what their values are. Okay, and then we just do this shit. But now instead of doing center times center, we're gonna do like pow abs this thing P. Okay, and so now copy periodically to text editor. That's a pretty good point. We should do that, huh? Shader. Paste, please. Uh-oh. Uh-oh. He's not letting me. He's trying to keep me. Let me out, sir. There we go. Okay. So here we just call Bell now with center, dist 2, and C. Okay, so you play here. Fuck. Center dist on card identifier. Okay, X. Are you happy? Bell, no matching overloaded function found. Why? Float, C, float center dist. Oh, god damn it. Okay, cool. So that works fine. Okay. Then what? We want to add like the crosses now. So the lens flare, as we were calling it. So now we are saying that we have. Okay, let's go back to Desmos. So I guess. I kind of want something. I don't really know what I'm looking for, to be honest. So I guess it's probably something like this, right? Where we want those things to be like visible for a long time and then taper off at the end would be my guess here. So if we were to do like an X, like on X-axis flare, something that goes along the X-axis, I guess we would say that we have like flare X is going to be something like Bell with UVX with power of, do we write 10 there? Yeah. And C of like 0.03 or something? Is that what we wrote? 0.3, I guess? I don't know. So can we just write flare X here and see what that looks like? Oh, abs uv dot x minus 0.5. My bad. I guess we just want center offs dot x. Which is not doing what I wanted at all, huh? Because the distance is too large. We want it to be around 0.5, not wherever the fuck we were. So maybe like, can we make this thing step 0.01 or something instead? So like something like this. Like, whoa. Like that? Like 10 and 0.01? Maybe? I don't know. I don't know, man. Okay. That's kind of what I was looking for. I think. Thanks for the links about like shader slang and WebGPU, but I just think it's I'm gonna do this for now. Have you read this gem? No, I've not. Book of Shaders. I just kind of guess and check. I'm not gonna read this right now, but this does look pretty sick. This looks like a good intro. Ooh. He's doing some sort of like sawtooth thing there. That's kind of interesting. Okay. I guess we want to limit this somehow. Hand wavy. Right, so we want, I guess we want like flare X is like if the Y value is greater than some number, so we probably want like another one of these to come in like vertically, right? If we want some fade in, we probably want like some like fade in on this axis as well, right? So some sort of like steep thing, right? Like maybe even something like this. I don't know. We have one thing, and when you have a hammer, everything's a fucking nail. But we can try that. So this is gonna be the flare X. This is gonna be the flare X Y, which is gonna be bell center offs Y, and we're gonna use 2 and 0.02. Okay, and if we look at flare XY now, do we see something that looks about like what? Fuck! Yeah, that's kind of what I was looking for. Maybe even more aggressive, to be honest. Okay, and then I guess, like, can we just use, like, the maximum of these? Does GLSL have, like, max many? Or do I have to, like, chain my maxes? Yeah, I guess we just do, like, float flare X is going to equal the max of flare XY and flare XX, question mark? Fuck. Min, maybe? That's not, like, not what I was looking for. It's kind of, like, spiky on, like... I don't really understand what's happening here. Maybe we multiply them instead of min them? That looks more like what I was looking for. You can also multiply them. Hey, I got there. I got there. Okay. And then I guess we just multiply this by R as well. And then we should get, oh no, we don't. For the other thing, for combining with the center thing, I guess we probably want max, right? We probably want max. No. Surprisingly, that looks like shit because this thing is a solid bar all the way through, but we kind of want him, I guess, to like come out of like the faded out section or something. What does it look like? Like, why does it look like shit? Yeah, I guess because these like flare things kind of start with like some sort of outer edge parameter. Right? They start kind of dimmer. Interesting. So maybe like if we were to just kind of like eyeball it, even if we just dim it though, it still has this like abrupt thing happening here where it like collides. So it's almost like we want to like mix it in somehow. I wonder if we just like take this thing and we apply it on top as like alpha. Like we like alpha blend it together. If that makes sense. So how the fuck does that work? It's the same as mix, I think. Right? So we do like call this like center additive. Do we just add them and then clamp? Adding and clamping doesn't seem insane. I mean, we could try it. R is equal to flare x plus center. That does look like less weird. I mean, I think that we probably want like this thing now to be like flare x times 0.5 or something, like limited in some way. I bet you that looks kind of okay if we just kind of make the fall off even hard. Like if we draw this down to like 0.2. That looks kind of okay. That looks kind of okay. This is the new James Webb Telescope image. Hell yeah. I guess we could also kind of increase the aggressiveness of like the Y fall off to see if that kind of changes the way the center looks. So, like this. That's kind of neat. And then I guess like we could go bigger on this as well. Let's try going bigger again. And can we maybe make the ball fall off harder? Right, so there's power, which we can do to raise kind of how long it stays active at the top. And then C is kind of how fast he hits the lowest value. So we could do something like 1.5, 0.15 or something. This was lower before. I don't know, man. That's too small. That's... Oops, I went the wrong way. Yeah, I don't know. That kind of looks okay. I'm kind of okay with that. Feels like the perfect time for some uniforms. Yeah, we are going to have to hook these up as uniforms later. I don't know if this lets me put them as uniforms, but it does seem like we are going to need... you can also change size by scaling distance to center. True. True. But I think I don't want to do that because I kind of want like a fixed thing that maybe we like grow with the weight of the point or something. I'm not really sure. Not sure. Okay, I mean, we can just do this on Y as well. So let's do float flare, make flare, I guess. I guess like, oh yeah, it's fine. Make flare, and we'll say, we'll call this the like long axis and the short axis or something. Does that kind of turn this into something? So we say this is long, this is short, and then we just return this. We're gonna have to fix the names later, but that's fine. Make flare center off x and center offs y. And then we do this again with y. But we invert these now, y and x. Okay. And then I guess we just do plus flare y times 0.2 here. Fuck, he's mad because long, oh, fine. Long axis and short axis or something. Can I get rid of this fucking, that's fine. Long axis and short axis. All right, there we go. There are stars. And then we can probably add like arbitrary rotation or something to them as well. But that looks like pretty fine. Flare X is using center off Y in that calculation. Is that correct? Yeah, it's just we didn't change the names. It doesn't really matter. Like, I'm sure somewhere in here there might be backwards, but who cares? Yeah, that looks okay. And then we could like rotate this thing kind of arbitrarily, right? So we could have like a rotation is 0.0, and then we could kind of rotate this center offset by some amount, I think. How would we do that? You would have like rotation transform is like mat 2x2 of like each column, so vec2 and vec2, and then these are like sine and cosine rotation matrix. We usually derive it, but I don't really feel like it right now. Cosine is the first one. So here we would have like cos rotation, sine rotation, and then we can do like first column cosine sine, and then what was it? Negative sine cosine, the other one. And then we can multiply the center offset by that thing, I think. So if we hit play here, nothing should change except for we have a syntax error. Where? Oh, trailing comma every time. And then here, if we turn this up to like 1, we made a mistake here where the y, it's like not square anymore. It makes me think we should be expecting 3 y's then. Yeah, exactly. Probably because like inverting axes here is not doing what we expect anymore for some reason. I actually am not sure I understand why. Is it possible that I got the negative in the wrong spot here? No. Why is that no longer square as we increase the rotation? I would have not, I don't expect that. Everything is related to this center thing, right? So everything should be working in like the rotated space. Nothing is using UV after this, right? Maybe the ab 0.5 goes after. Could be this. Nope. Oh wait, it feels like it should be though, right? So we multiply UV times the rot transform. So this should rotate around 0, 0. And then here, we want to make, yeah, there's something about like center rotation shit going on here. Something about it. Aspect ratio strikes again, but at this point the UV coordinates are like aspect ratio corrected, so I think it should be fine. I think it's more about the rotation is like the X and Y axes are becoming like more and more aligned as we rotate. So what we have here is we have a UV 0, here. We subtract 0.5 so that like this center of this screen goes down to here. Okay, so that seems like it should be fine. Right, like this now. Ah, there we go. It was because of the absolute value in there. Yeah, so now we can rotate this to any arbitrary angle. Yeah, sick. Sick. It was because we had an absolute value here, right? And so we were kind of always in like the top right quadrant instead of trying to like rotate around here, right? So it's like, if we have this, as like this guy comes down because of the absolute value, but usually it would be like this guy goes down, this guy goes up, you know? Oh, I don't like what that's turning into. That was not intentional. Okay, guys? Don't get mad. Okay, so I think we have like kind of a star that we can make now. And I think that the only thing I want to do here is I think that I want to cap the distance of the flare. So I think that like I want, as the weight grows, the flare to get bigger. Clipped and shipped, you're done, buddy. Fuck. No. Because well, unless it could be that if we just draw this thing really small, the flare will become insignificantly tiny and we won't see it. So maybe we can just pretend the flare is always there and we'll see. We'll parameterize it if we need to. Okay, so let's make this thing now something that we can use in our program. So source, shader, and I guess we'll just take this thing and name this like star. Okay. Cool. In shader toy, change the time. Yeah, we might as well. Does this work this way? Do we do it here? Non-constant to, oh, do we just write, it's not constant, fine. Oh, interesting. It's broken again. Okay, I thought we fixed it. Oh, because I put the abs back like a dumbass. Much better. Go faster. All right, we'll copy paste this one. Okay. So now we just have to do some conversions here. So we need to convert this into something that we can use from our OpenGL round. Do I not have like a GLSL shader syntax highlighter? I guess not. Well, get fucked me, I guess. Okay. So what do shaders look like normally? Frag. Okay, so we throw this shit at the top. We say that we have like out vec for fragment. So now this thing becomes main here with no parameters. Our UV is automatically specified, so we do this, boom, and then the rest of this stuff should be fine. So we also have like a uniform of rotation, like this, okay? And all right, sure. So we make the transform, which I guess is fine. Our UV coordinate generation is automatic. Center, distance, then all of this is the same. And then it's just a fragment is what we call here. And then here we probably want like, we probably want to draw this thing as a color with the amount as like an alpha, right? That's probably what we want. You typed int vec2, not in vec2. Nice. Good eye. Thank you. So we probably want like a color here as well. That's kind of my guess. Okay. So now, is the color a uniform, or is it something that we pass in as like an attribute of the plane? I guess color as uniform is fine. So we can render everything once. I kind of feel like rotation shouldn't be a uniform, actually. This should be like a vertex attribute, I think. Yeah, I think so. But we'll figure that out later. For now, let's just say that everything is axis aligned and just kind of see how it plays out. So now we have circle shader is going to turn into star, I guess. So this is going to be like embed file of shader star GLSL. And let's look at star shader. And I think everything else just kind of will work. I think. Color vec4. I think I want a vec3 on this thing. Because we apply the alpha in the vec4 at the end here. So I think it's fine. He's not happy for sure. Uniform type mismatch is definitely not giving us a good sign here. But it would be interesting if, let's try like cranking up the visibility of this thing. And let's get rid of the line alpha. Line fret, what is it? Constant color shader is what we called it. This thing, can we just like not do this? So here if we go into like text renderer now and we crank this shit up, that's pretty fucking sick. That's pretty cool. That is kind of like what I was imagining. Now, they're too uniform for sure. There's like this kind of like odd, I think it's probably, I wonder if like lens flare is constant for each one. It could also be related to like the propagation of weights to these things. Like the weight of my references is not the same. Like it should be like each of these stars that are connected to the text renderer need to be kind of like less, not the same brightness. I think that kind of fixes the problem. It is constant, depends on the rotation of the mirror. Okay, that's what I thought. Also, the number of flares depends on the shape of the mirror. Yeah, that's what I thought. It's like an attribute of like the camera, not an attribute of the star itself. Okay. Cool. So I guess we could probably change the weight of the people by us based off of oh, we already kind of do try to do this, huh? We say like multiply the weight times 1 times what am I looking at? 1 times its existing weight for every time I see it as a reference. Yeah, that sucks. That sucks. I think I want like the default size also to be bigger now. radius. Radius. Default circle radius. Where does this come from? Point radius. So we just want this to kind of be like kind of bigger now because the center of the thing takes up so much less space. That's too big. Was it this before? 01, I can't remember. Yeah, it's gonna go like 02 maybe? I think that I want the flare to not be visible. Like, I don't know if you guys can see this, but I can definitely see it a little bit on my screen. I see some like faint, god damn it. Like I see like this, which I don't really like. I feel like the flare only comes in once the star passes a certain size. You know? So can we like parameterize that in some way? If we take like, it's some scalar on the bell, right? So if we look at like this thing, we have a flare that looks kind of like, you know, something along these lines, right? And so I guess we just want to like decrease power on this thing with its weight. And I wonder, do we pass in the weight right now? Do we pass in the weight for this star? Update node buffer. So not really. Not really. Okay. Which means like we need to encode this information somehow. And we don't really support this. We did kind of make some changes. We were trying to support more generic OpenGL programs in Happy Hour today. I can't remember if, I feel like we weren't compiling at some point, but maybe we can kind of bring that code back just so that we can like inject an extra parameter. So we can add like a vertex attribute that's like weight here. Then we can pass the weight into every thing, and then we can adjust the length of the thing based off the weight. I think that makes sense. So we want this thing to grow up to a certain size, probably, but the weight starts at 1, so we can use like a power value that is just equal to the weight, and then as the weight increases, we can grow until it caps. Okay, so let's do star. I guess we need to add the shader. It's an important aspect of this. And then we can kind of look at the thing we were looking at in Happy Hour today. So we were looking at improved shader API. Does this compile right now? I hope it does. It does. Hell yeah, dude. Hell yeah. And then here, we can go get diff back by 1. Sure. Can we like get rebase onto whip question mark? We take the 0 here, and then circle prog is going to use the star shader. Okay. Cool. Looks like everyone's happy. And does it fucking work? Question mark? No. Of course it doesn't. Of course it doesn't. It never fucking works. Okay, so what's happening here? Render 1066. Render new API. He's looking for the color uniform in the circle shader uniform, which is pissed because of something. God damn it. I think maybe we use the render old API, and maybe this will just kind of keep working. Maybe we'll kind of, let's try this. Okay, so this is back. This is working. And now let's try to add a weight parameter to this thing. So circle, we're going to use a new shader. We'll call this the circle vertex shader. And he's going to take in a position and then also like a weight. And we will pass that weight to the fragment shader as weight. Okay, so weight here is equal to weight. And then the star shader, I guess we should call this star vertex shader actually. Star GLSL, this guy now needs to take in weight. And he's going to use this as the power value, we said, of the flare, right? So in make flare, we take in weight here. And then this just says like, this is like max weight 10.0f. And by max, I probably mean the minimum. Yeah, something like this. Seems kind of reasonable. Yeah. Okay. And then that means that our fragment shader now, when we use the circle shader, star. So here we'll use the star vert shader. And now we need to change the like point elem here to have, instead of vpos and vuv, we vpos vu. Do we need uv? We do. We do. Okay. So here we actually have uv. I guess we'll prefix things with v. That's fine. vuv, vpos, vweight. Then fweight turns into weight. I like that better, I think. We're still playing around with what works and what doesn't work. We don't know yet. We don't know yet. So this is now just weight, and weight turns into weight everywhere. Okay. We'll see how that feels. I guess technically this thing doesn't need weight passed in, right? Because he already has it available. Kind of as a global here. And I guess we could pass in rotation here as well if we wanted to. But the rotation, like we said, is an aspect of the camera. So it's not that we really care that much about being like perfectly accurate, but you know. Where did we lose our star vert shader? So this is gonna be vpos, vuv, all lowercase, and then v weight as a float. F32, sorry. Okay, so now when we update this node buffer, we need like v weight is equal to weight. Just we kind of slap this on all of these guys, right? And then everyone should be fine. Can we just vpos, vpos, v uv, vuv? Okay. Let's see if that works. Fuck. Pause undeclared. True. Fine. Fine. We'll use the fucking identifiers that we said. Okay, so that's not good. That's not good at all. Okay. let's take this out. And let's just go back to this and make sure that, like, is it working if we change nothing? Or what? V weight undeclared, fine. Can we just put weight equals 1.0 unconditionally? That's also not working. That's not good. What if we just undo, like, everything? We go back to this thing. Okay, so that's working. This is working. So it was when we changed to the star vert shader, everything went to shit. Oh, I guess did we lose no, we didn't. So V pause, V UV. Let's literally change nothing here. Oh, I guess we weren't propagating the UV position. That probably has something to do with it, huh? So we need UV and weight here. And we need to do like UV is equal to V UV question mark? Is that the problem? He's mad because F weight is undeclared. God damn it, god damn it, god damn it. Weight is equal to, what was it, 1.0? We're just kind of hacking it for now. We're just hacking it. Fuck. Vec2 on UV, my bad. My bad. Okay, so that's working still, which is great. And now we want to go back to adjusting our type to pass in the weight properly. So star vert shader takes in vec2 v weight. Weight is equal to v weight. Point lm v weight. And then here we say weight is v weight is equal to weight everywhere. Boom, 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 boom. All right, let's try that again. Fuck. Fuck, 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 fuck. This, okay, so this needs to be float. My bad. My bad. Okay. So now we do see these things grow. Okay. What if we do like math? Yeah, I mean, that looks kind of nice. That does look kind of like what I was imagining to some extent. Now, can we now increase the default point size here? What was it? It was like point radius. So can we increase this now to like 4 and without it like causing problems and having like every single thing flaring the fuck up? I almost want like, so the problem now is that these guys look like fucking whack. I don't like how like the fall off on these feels like they need to be more aggressive as well, to be honest. Like just kind of like on like the center. It's just kind of how I'm feeling right now. So I guess it's kind of like this center bell needs a bigger C value. Is that what we said it was? So we have like power to C lower. Yeah, so we just lower that bad boy. So like we do like 05 here. Does that look less shit? Sure. And then text renderer. Yeah, I'm not against it. I'm not super against it. I don't know, I feel like that looks okay. I feel like that looks okay. So let's kind of be more realistic here and try to pick like an actual function. Yeah, I mean, that's kind of hype. That's kind of hype. And then let's it would be cool if we could like show, how do I want to say this? Like say that we're focusing on like text layout, right? Would it make more sense if this thing um was like tinted? And then the people it's connected to are also tinted, but like a little bit less. Like we tint them according to their weight almost. You know what I mean? That would be kind of interesting. Um yeah, so how would we do that? We need to feed in like the color that we want this thing to be, which I'm feeling like might belong to the as like a vertex attribute, so that we can kind of draw them out at once. It kind of feels that way to me. So maybe we like color each thing, and as we update the weights, we update their colors as well. And maybe the weight value, I wonder if the weight value should be relative to like maximum. You know what I mean? So like instead of this thing just being like my weight value is like 150, maybe my weight value is always between 0 and 1 in within the shader at least. That seems kind of reasonable. Maybe everywhere, to be honest. Maybe everywhere weights should be between 0 and 1. So maybe like we kind of go through and we mark some things as like interesting, right? So we say like, okay, I'm spending like a lot of time in text render, so like the absolute time spent there goes up. And then we do like a post pass. So after we like update all of the like weights by propagating them down to our like references and stuff, maybe we then normalize all the weights back down to 1. And I wonder if it makes sense that we want like all of the weights in the entire thing to add to 1 or something. Nah, we'll just normalize everything down to 1, I think. So if we go into like viz, and in here, when we update the weights, we change the weight here. We loop over all these things, and then just here we go, I guess somewhere we need to pick the maximum weight. What does change weight do? He returns a node ID and a weight. I see. So I think here as we iterate all of the weights, here, what is happening here? Oh, okay, sure. We reset these things with the user weights. That makes sense. So the user weights are the things that we are updating in the UI, and then we do shit to the actual weights that we propagate. Cool. So then, as we're propagating the actual weights, I guess here we say like the max weight is 1.0, right? Here we say max weight is equal to the maximum of max weight, and user weights get ID. So here we should actually just say like weight is equal to this. Wait here. And then we do the same thing here. So this is like some like fucked up shit where we do this times this. I guess. So now we say this thing is equal to weight, and the max weight is max weight and weight. Okay. Then we just say for weights, we say weight divide equals max weight. We have to do this with like iterators and stuff because we're idiots, but it's fine. This is ID, and then weight is equal to weights get pointer of ID, and then this is weight star divide equals max weight. Okay, cool. And so now I don't think this has an effect on the graph anymore, so it's literally only for rendering. And now I think what's going to happen is when I do text render, I think everything else is going to get smaller except for the text render, which is not what we want, right? So we need to make it so that the point radius also increases with max weight. Okay. So point radius like something like this. Why is everything so blurry? Why is everything so blurry? Because like the radiuses are growing more than they should or something? Bloom reinvented. Yeah, oops. Yeah, what have I done here? Like, I feel like this should not be increasing that much, right? Because here we've kind of said that every weight, should be, if we take 0.04 times the max weight, then divide the max weight, we should just get back to 0.04, right? So the fact that everything is growing is a little bit concerning here, right? Like, only the thing that we're trying to grow should be growing. So like, unless the weight parameter is becoming like used in the shader in a way that it shouldn't, let's just double check this. Like, are things capping out at some size? I don't really think so. I don't really think so. Losing precision or something, but it sure is pretty. Yeah, I guess maybe. It feels like it shouldn't be, but I guess it's a possibility. Like the precision here is literally like, this is happening if this thing's like 10 or 20, right? Like that seems wrong. That seems really wrong. So what have we done wrong here? Max weight and weight. Can we just look at like first element here has a weight of this? Actually, we could even just, yeah, it's fine. Let's look at like weights data 0 times max weight. So we're hoping to see this is like 1.0. Yeah, right. And we're seeing like 1 all over the place, right? 1, 1, 1, 1, 1. Like maybe a little bit off, but like he's still like close to 1. So that's kind of interesting. I'm curious to see if we take all use of weight out of the fragment shader. Right, like let's just go back to this. Let's see if it still looks kind of fucked up. So, because it could be that that is causing something. Nope, even then, we are just still like, we are definitely just unconditionally growing these things. Which seems bad. So, when we call this thing with default circle radius, I see. We were doing some sort of mass thing. So when we were square rooting it, it was getting big. That makes sense. Okay, let's try this again. Okay, so that looks way more reasonable now. And now we want to go back to figuring out how to adjust the flare thing. So now we want to make sure that let's think for a second. So the weights now are all between 0 and 1. And weirdly, in the default case, every single element has a weight of 1, right? Which means that we can't like limit the flare effect anymore that easily. Because that flare effect before we were saying like, okay, only if you're like a very focused thing. So that's kind of fucking annoying. Why were we trying to put the weight between 0 and 1 to begin with? I don't remember. It was something about coloring. So we wanted to use the weight as like a saturation value. But what we can do instead is we can go back to doing whatever the fuck we were doing before. And we can just pass the maximum weight as a uniform. So instead of scaling everything according to the weight, we can still allow absolute value weights. And then we just say max weight is max weight. Which means that here we should just set like, we just kind of move this guy into like a global effectively up here. And then just before we reset, before we go through this, we say max weight to 1.0. Okay. Then in our star shader, in our vertex shader or fragment shader for this thing, we just want to take in a uniform of max weight here. Okay. So we should be able to do. Oh, wait. Why aren't we using this? Hold on. Where is our like hello circle prog render? Oh yeah, we wanted to try render new API, and well, let's just try changing the color here. So was it circle shader uniform, and it was like color is equal to let's make it like red, just to see if that works. Okay, yeah, so that's working fine. And then we can put the maximum weight in here as well. Like this. And then we should be able to use that somehow. So in here, we said what? It was like we were using like the raw weight here. And using the minimum of the raw weight and this or something. It was like Yeah, it was something like this. Let's go back to that. Fuck. Unsupported uniform type. We can fix that. Here we just need to make sure that if we have an F32, we do float is equal to field of reserved uniform and reserved name. Okay, so this should get the float field out in a way that can be passed on to our program. Okay, cool. So now we go back to saying text renderer. Let's make this thing big. Boom. Okay, good, good. And now let's go back to then trying to apply a tint to this thing. So let's think about this. Say we add as a vertex parameter a tint. Okay, so our circle shader uniform, he's not gonna take color in it, and instead it's gonna be part of the point element here. So here. Then our star fragment shader, or vertex shader, he needs to take that thing in, and he needs to pass it on to the fragment shader. Okay. And then in the fragment shader, he is going to use that tint. He's going to say, like, I want, by default, I'm going to be white, right? Or maybe, like, by default, we're going to be whatever color was passed in as our uniform here. And we're going to say, like, mix. This is going to be, like, the output color. Is going to be mixed from the default color to the tint color by the weight over max weight. Yeah. And then we use out color here. So then I guess we just have to go in and we have to add the tint color thing. What are we making? We're trying to graph our code base in a way that looks like the stars. Give me 1 second to just clean up this last change that we're making, and then I can show it really quick. So here we just need to make sure that on point elem here, v tint is just, we're gonna put an unconditional like red in here or something, just for now. I'll come back to this and figure it out in a second. And then can we set was our default color? He was white. Okay, so the vast majority of these guys, fuck, unknown type at 145. Oh, because he doesn't know how to do this. So vec3s have 3 parameters, and vec3s are floats. Fuck. Tint undeclared. Did we fuck something up? Star vert shader. V tint goes to tint. Oh, we need to say out vec3 tint here. Pass it along to the fragment shader. Fuck. Okay. What's he pissed about now? Unexpected toke. What did I do wrong here? This is fragment shader. So here. Oops, I did int vec3 again instead of in vec3. Oopies. Fuck. Geez, where? Okay, so he's saying 44 over here. We did just forget a semicolon. Classic. Okay, so now things are red by default. And let's say that we want to make our text renderer. That's kind of what I was imagining. That's not, I mean, the fact that they all start red is fucking stupid, But now the idea that we can say that we have one thing tinted red and everything that's like kind of related to him is like also kind of red, that's kind of exciting. Because now we can have like multiple colors of different things that we care about, and that will like kind of tint their references a different color, which is pretty sick. So for the guy who's asking what are we making, the idea here is this is like a representation of our image editor codebase. As we've gotten farther and farther into the project, there's like more and more code, right? Each dot in this diagram is like it is a type or a function or a file or a folder. Hand wavy. What we are trying to make is we're trying to make some utility that lets us provide meaningful information at a glance. So the idea here is that we're going to hook this thing up to our text editor. Our text editor is going to inform this like visualizer of like where we are spending most of our time. So we could maybe like take like a rolling average of like the last 10 minutes. Where are we in the code base? And what we can do is we can try to show, oh, so that part of the code base is the text rendering subsystem, and that text rendering subsystem talks to the OpenGL subsystem and the math subsystem, and we can like maybe try to like display a legend and use some colors and show some hierarchy in some way that we haven't quite figured out yet, and just try to show something. The hopes are that when somebody comes in, this thing will be kind of like off in the corner of the screen, right? And they can see like right now how like when we were jumping around the code base, how do these things relate to each other? That's what we're imagining. Okay. So I was kind of hoping that we would get to some sort of like background stuff, right? I was hoping that we could start working on trying to like show hierarchy using some form of like background wispiness or whatever. But the star thing ended up taking like way longer than I thought it would. So we're at 340 now. I think that this is probably a natural place to call it, to be honest. We've got like these like stars looking pretty decent. There's definitely some like minor fixes that we got to make here. But overall, I'm pretty happy with the way that looks. The next steps I think are going to be, like if we look at like, I guess we can like imagine. We can imagine that we have like say like this section of the code base is all like UI stuff, and this section is all like main app stuff, and this is all like this is like all main app stuff, and this is like math stuff, and then within like this section we have like kind of like islands of like different classes and files and folders and stuff. The next thing that I want to do is I want to like background these sections with something that looks kind of pretty galaxy-ish, right? So maybe like we like color these things in some way and add density, like color them more in areas of higher density or something. But I'm hoping to show like like these, if we look at file light and we open our home folder, give him a second. Give him a sec. He's thinking. He's scanning way too many files. I should have picked a smaller folder. But this thing will eventually show us some sort of like hierarchical information about like which folders in our file system are taking up the most amount of space. So the next step is going to be trying to like do something similar, right? So this shows it as like a radial graph, right? So this is like my home folders or the work folders taking up the most, and within the work folder is all these things, right? But you can imagine that we could apply this same sort of like coloring system, right, where each folder has its own color to like this thing. And maybe like as you get down and down into deeper subfolders, instead of keeping the same color, maybe we get like more saturated or something. Might I have a minor suggestion for the future? Avoid the tints mingling and add some sort of weighted RGB exclusion to prevent things going white. Yeah, okay. Makes sense. Anyways, so that's probably what we'll be looking at tomorrow, is trying to use our like convex hull generation that we used yesterday as a way to like group areas of the graph and then try to have some form of like hierarchy shown. But this is it for today. So thank you for watching, guys. If you liked what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 3:45 Pacific time now, so if you're all watching live, you should expect us to see us online from like 3 hours ago and a bit to now. If you're watching live and you're like, damn, I want to see the next thing, but I'm not going to be online tomorrow, there's a YouTube link in the Twitch description. This is organized into playlists that we're working on building a map of my code. The code will also eventually end up on GitHub. We've been pretty slow with pushing this stuff. I think it's because like a lot of experimentation and never anything that's like really finished, because it's kind of more like artsy than our typical code stuff. But this will go up there. You might notice that the VODs are 2 hours, but we said we stream for 3.5. That's because we have kind of like code cleanup time, which we call happy hour, from like 12:30 to 2. You don't really miss anything if you don't see those. But if you want extra content, that stuff is hidden behind the join button on YouTube, sub on Patreon, or sub on Twitch. And VODs will go into the appropriate places. I think that's all. YouTube, peace out. Twitch, let's find someone to raid.